In this presentation, we are going to look at correlation when there is missing values in the data. So suppose we were computing a correlation coefficient, we'd use the COR command specifying the name of the variables. So let's look at the MTCars data set. We have two variables, HP and WT, and it's a pretty straightforward job to calculate the correlation coefficient. I have a little bit of extract code there, but let's do it out. So I'm going to attach it just to save a bit of typing, the MTCars dataset. So HOR, and we're finding the correlation coefficient between horsepower, HP, and the weight of the car. So it is 0.6587, so on. Now, suppose you are trying to compute a correlation coefficient for a data set where there are missing values present. For example, the air quality data set. Air quality is another inbuilt data set. So what would happen is we would get an NA value if there is missing data. So again, I have some extracts of code there, but let's do it out again. So I've attached air quality, and we can get a quick look at the top of the data set there. We can sort of see that line 5, case 5, there is NAs for ozone and solar.R. Now, if let's say I want to find out the correlation coefficient for ozone and wind, I'm going to get the NA. That means this NA here and all the other NAs in ozone and in wind would cause us to get this result. So there is a special argument with the COR command to help us overcome this. So if the additional argument use is specified with the value complete.obs, then the correlation for each pair of variables is computed using all complete pairs of observations on those variables. So what would happen, what I should do here is use just the complete cases, where all the cases where there is no missing values. So I'm going to just copy and paste that out. Let's go back to R here for a second. There we go, minus 0.6015465. So again, complete obs. And that ends our presentation.